Page 3 of vectors. Displacement is a blank with a direction associated with. If you remember from maybe physics, displacement is kind of a fancy word for distance. The main difference between distance and displacement is distance is like a magnitude. It's just a size. And displacement is a distance with a direction. Okay. Geometric vector addition. Vector PQ plus vector QR equals vector PR. So draw a diagram showing that the sum of a trip from town P to Q, then from Q to R, is the same as a trip from P directly to R. So let's say that you have P. Let's say that you have P here, and Q here, and R here. If you do P to Q and then you do Q to R, that is, in the end, the same as just taking a trip from P directly to R. Okay, so that's all this is saying. The zero vector has a length of 0. For any vector A, the vector A plus the vector 0, the 0 vector, equals the 0 vector plus vector A, which is just equal to vector A. Okay, so you add the 0 vector to any vector and you just get the vector back regardless of what order you do it in. Then there is the negative vector, like kind of the opposite of vector A. If you add the opposite of vector A to vector A, you get 0, the 0 vector. Okay, so and that's in regardless of which order you do it in. You could add the opposite vector first or the opposite vector second. In the end, if you add the opposite vector with the vector itself, you get the 0 vector. How do we write the 0 vector by hand? I think like that. Okay. Let's see. Use the given vectors P and Q to construct P plus Q. Okay. So we got P and Q, and I'm just gonna when you add vectors, all you need to do is put the tail of one to the head of the other. So I'm just gonna put the Q vector there on the end of the P vector. Okay, and then that means I have just constructed the P plus Q vector. P plus Q. Now let's do it with this one. On this one, P plus Q would be like that. So the P plus Q vector would be that. And then this one looks kind of weird. Maybe it was like that. I'm not sure. So it would be like that. The print didn't come out too well. Okay, so I think that the P plus Q would look like that. Okay. Find a single vector which is equal to, let's see, AB plus BC vectors. We're just going to do just like we did with going from town P to Q, then Q to R. It's the same thing as going from P directly to R in the end. So this would be the same as going from town A to C directly. This would be like going from A and back to A again. So that is actually just the 0 vector, right? And AC plus CB plus BD, let's see, you end up back at D, so that would be the same as the AD vector. 3A. Given vector P and vector Q, use vector diagrams to find P plus Q. Let's see. I'll use a space right here. So we'll have P, which is 4 across and 3 up. And I'm going to add q, which is 2 down, 1 across. And then what is the result of that? That is that vector there. So that's that vector. And then what about q plus p? We're going to change the order. So first we're going to go down 2, and I go over 1, and then we're going to go over 4 and up 3. Over 4 and up 3. And then, okay, and we got the exact same thing. So for any two vectors p and q, is p plus q equal to q plus p? Yes. Geometric vector subtraction. To subtract one vector from another, we simply add its negative. So a minus b, vector a minus vector b is equal to the vector a plus the opposite, or the negative vector b. So let's see. What does the negative b vector look like? It's exactly the same except if it's in the opposite direction. So let's do vector a, which is going 5 across and 4 up, 5 across, 1, 2, 3, 4, 5, and 4 up. Okay, so it's going to go like that. That's vector a. And then we're going to subtract vector b. So instead of going in the direction of vector b, we're going to go in the opposite direction of vector b, 2 down and 3 across. Looks like that. And we're done, right? Okay. So the resultant vector here would be that vector here. That would be a minus b. Okay. Page 4. For the following vectors, p and q, show how to construct p minus q. Okay. So first we need to figure out what minus q looks like. It would be exactly the same except the arrows on the opposite side. It would be exactly the same except the arrows on the opposite side. Okay. So now let's try to draw. Let's see. I'll do p. So p is 4 over and 3 up. 4 over, 4 over, and 3 up. Okay, and then the q is 1 back and 3 up. 1 back and 3 up. Okay, so that would be a. Okay, and then this other one, let's see. The p vector goes to the left 1 and up 3. And then the p vector is, wow, 1, 2, 3, 4, 5, 6. It goes over 6, 1, 2, 3, 4, 5, 6, and it goes up 2 in the opposite direction of the original vector. And so the resultant vector would be that. Okay, so those would be the p minus q vectors. P minus q for A and p minus q for C. Okay. For the vectors illustrated, show how to construct p plus q minus r. I'm going to take these and move them over so I can use this. Just going to put them right over here. Okay. And now I'm going to draw these over here. Okay, show how to construct p plus q minus r. So minus r would be the same vector but in the opposite direction, right? And minus q would look like that, and minus p would look like that. Okay, so first let's do p plus q minus r. So p, let's see, it would be going over 4 and up 4, 1, 2, 3, 4, 1, 2, 3, 4, like that, right? 4 and 4, yeah. And then plus q means we would go down 3. And then minus r, we would follow the red arrow there. And oops, I drew it too low. Thank goodness for technology. So this one I'm going to draw red because it's a negative vector, and I'm going to make it 3 over and 2 down. Okay, and then the resultant vector I'm going to draw like that. Okay, so that was A. Okay, and now let's draw R minus Q minus P. So R is like that, back 3, up 2, that's R. And then I subtract Q. So Q is, thank goodness for technology. Q is going up 3. And then minus P would be going to the left 4 and down 4. So it would be like that, right? Down 4 and left 4. Okay. And it's the exact opposite of the first one. See, it's like, it looks the same, but it's pointing in the opposite direction. 3. For points A, B, C, D, simplify the following vector expressions. AD minus BD. Okay, here you're just going to do a trick. Remember that the negative vector is just the opposite direction. So you can just switch. Instead of plus BD, you could do plus DB. And instead of minus CA, it could be plus AC. And instead of minus CB, it could be plus BC. And instead of minus DC, it could be plus CD. Now you can just like see if you can simplify these. AD and then to DB is the same thing as doing A to B. BA plus AC is the same thing as BC. BC plus CB is the same thing as BB. Wait, BB, starting at B and going to B, that's the same thing as a zero vector. And then AB to BC is the same thing as AC. Then going to CD is the same thing as AD. So AD is the answer for that one. Okay. Now, number 1 here. Vector equations. Construct vector equations for... So let's see. For this one, we could say that R plus S is equal to T. For this one, we could say, let's see. These just kind of go in a circle, don't they? We could say P plus Q plus R plus S equals the zero vector, because it just comes back to where it started. What about this one? We could say P plus Q minus R plus, or no, not plus, minus S is equal to T. Okay, or something like that. Okay, or you could say maybe P plus Q is equal to T plus S plus R, something like that. Either one of those. 2A, find in terms of R, S, and T. Let's see. What's OB? So OB is actually that one. So find OB in terms of R and S and T. Well, it looks like if you do R and S, then you're going to get OB. So we're going to say R plus S. What about CA? CA. So CA, you could get by doing minus t, going the opposite direction here, and then doing minus s. That would get you CA. What about OC? OC. OC you could get by doing R plus S plus T. And that's it for page 3 and 4.